Okay, here's an update on the PV project with the 15K. We poured foundation for the cabinet here. It's not fancy, but I put some soil in the concrete so it wasn't so concretey. And we set the cabinet the other day, and we hooked up our load here. And I ran the PV conduit into the cabinet. This is the setup with the inverter on the back. So this is the battery connection to the batteries on the rack on the inside. This is the data cable. And I've got a ground to my ground rod here. As this is a complete standalone system, this is actually the first means of disconnect. So our ground is at this location. So I added this 50 amp circuit breaker here because that's our output here. And like I said, this breaker or this breaker are the first means of disconnect. So the bonding happens at this point. This is our 3 strings of panels here. This is 10 gauge wire. There's 2 panels in series, so we're running about 21 amps per string. And 3 strings, 6 panels per string, 2 strings per pair here. So this is 2, 4, 6 strings, and that is a total of 36 panels. And yeah, all of our EMT conduits have grounding bushings on one side or the other to make sure there's a positive ground and that they're not counting on the locking rings of the conduit. So our output here, yikes, it's hard to see. So it's morning, we're producing 7.9 kilowatts of PV, and we're charging the battery at 4.2, and we're using about 3 right now. I expect this 7.9 right here to ramp to about 12 or 13 kilowatts, probably like 13.2 maybe is my estimate. Like I said, we have 16.2 kilowatts of panels, but they're 5-degree tilt rack, and they're on a slope, so they get another like 2 degrees. So I would say their effective tilt is like probably about 7 degrees average. It's not optimized for our location, but let's see. Here's the cabinet. So I've been running about 40 degrees C average, which is 10 degrees below the operating temperature of the batteries. So it seems like I'm not going to need any supplemental heating in the winter. This cabling arrangement, I'm trying to get a thermal imaging camera over here, but this cabling arrangement is the negative comes into this bottom battery and then jumps up to the top, and then the positive ends here, I guess, and then it runs up to the top and then it comes out. So the positive is connected there and the negative is connected down here, so it's the diagonal. And so it is sort of perverting the charging of the batteries. I knew this was a risk when I set this up. I was just trying to utilize the double studs on the battery because that seemed like a cool feature. But I knew this was a risk. If you had seen any of the other builds, you would notice that I had taken care to have balanced, equal length battery leads to a common bus. I've never done this sort of daisy chain configuration. It seems like what's happening is the battery in the center of these 7 batteries here is getting the lowest state of charge, and then the one above it and the one below it is getting the highest state of charge. And then there's a little bit of a taper down for the next two. So this is the lowest, this is the next lowest, highest, and then the mirror of that on the bottom. So it's not really my favorite at all, and I've had a little bit of a problem with the batteries reporting a low state of charge and the Sol-ark shutting down, because the batteries were reporting a low state of charge. So I actually had to disconnect the battery data cables for now, so the Sol-ark won't shut down on me. And I plan a couple of different schemes, but I want to run the thermal imaging camera first for you guys so that you can see how the resistance is causing heat in the cabling arrangement, and then I'll change the cables so we can see how that changes. But I do have some plans for reducing that voltage drop, and I do plan to leave all the paralleling cables in place. I'm just going to take off from the battery bank at different locations, I think, at least for my first try. And I used 2-gauge or 2x0 battery cable, and I wish that I used 4x0, because at high current, I mean, not even high current, but like around 7,000 watts, the cables get pretty warm. They're definitely below 105C, which is their rating, but I just don't want to be making that much heat. So I wish I had done 4x0 cable, and or 2 parallels of 2x0 would have been fine too. So live and learn. So I don't know if you got to see the door insulation, but I used some VHB tape and stuck this steel stud to the door, but after it fell off, my friend had recommended some surface prep to the door paint, which I didn't do. You can see some of the tape here. When it fell off, it made a huge mess. Right there's the tape. It made a huge mess, and then I ended up welding studs to the door instead, well, in addition, and then I stuck it back on, and the studs on this side are actually just bolting the stud to the door, and then on this side I ended up having to make this little bracket, and there's 3 of them going down the door. It's a little casual, but it's gonna work. And yeah, I don't know if I covered the insulation mount here. I ended up using this strut and that strut to bolt this in here, and then I used construction adhesive in the corners here to do the rest of it. And let's see if I can get that. Yeah, they're back in the corner. It works pretty good. It's pretty solid. I don't think it's gonna fall off anytime soon. So again, no combustibles in the cabinet, 100% non-combustible sheathing and insulation, mineral wool insulation. So that's that. Oh, and I also hate these blue cables, so I started making white, nice white jumpers for them, and I'm going to secure them on the side there. But anyway, so the connection from the array is this 1-inch EMT conduit with weather-tight compression connectors, and there's a grounding bushing on this side, and then I don't know if I can show this here. The sun is really intense right now. And then there's this isolator here in the middle. The Sol-ark recommends not bonding it directly to the solar panels for lightning strikes. So it has surge arresters, I think. I have to go back and read the data sheet. But I think that there's lightning arresters on the PV strings, but not through the grounding. So the Sol-ark is grounded on this side, and then the PV is going to be grounded on that side, and this little piece of PVC is going to be the insulation gap. And then The conduit runs up here. So I've got the 1-inch into the Midnight 8-string combiner. I only have 6 strings, of course, but this is what would fit my application. So this is the combiner. This is a little casual wiring, but because I have 3 strings and not 2 strings, I took out the bus. So this side is just these 2 fuses, and this bus is string or cables, MPPT3 rather. And then this one I had to isolate because I needed 2 strings. So these 2 are on a string and these 2 are on a string. These are fuses, of course. So the string negative, this is the string 1. String 2 is this little wire nut here, which is a little casual, but it's these 2 MC4s here tie on to MPT2's negative. And then the third one is just this side, and I'm not using these 2 strings here. And I have an additional ground bar, or excuse me, neutral bar for this connection. I just haven't gotten to throw that in yet. I need to drill some holes. So that's how we did the combiner box. I checked the specs on these, and they can handle the double pieces of 10 gauge in there, no problem. So it's pretty good. And then, so I set this in concrete. We only have approximately 4 inches of soil on a huge rock here. You can see some of that rock coming out here. So there's really no no digging and no driving happening below there. So it's solid rock. And then this is just a sleeve conduit over to the panels. And then all of the interconnection of the strings runs up the side here. And I sleeved it in conduit, as you can see. It's not 100% sleeve, like I didn't put joints in it. But I didn't want a whole lot of exposed cabling. I don't know if I could get in there with the sun being so bright. I don't know. Maybe you can see that. You can see this pair jumps out for this string here, and then they fly bare and then get into these conduits again. I just didn't want huge volumes of cabling hanging off the side of the array because I thought that would be pretty gauche. So we have to do the ground cover, the fire blocking, and the rock surround all the way around it. But I am but one man, so I can only do so much. So, but that's the array, and she's operational. We're going to run our grounding up the side and relocate the ground for the array up the hill with this roll of wire here because, like I said, the rock is here. And although I can drive ground rods at 45 degrees, there's no way to get 45 degrees with the shape of the rock. So, I mean, at least I can't imagine it. So I'm going to go up the hill and over the edge up there and find some place where there's actually soil. And it'll be good because there's a valley up there, and it's more damp in the valley. There's more moisture because it runs down the valley, so I'll get even better conductivity. So for lightning, rusting, all of the grounds are going to be on the array only, not connected to the Sol-ark. So anyway, yeah, so that's the build. I may get around to following up with a thermal imaging camera and a battery rewiring video at some point, but I'm going to drive those ground rods now, and I'm going to be pretty close to done with this project. Anyway, thanks for watching. Bye.